Hello everyone, good evening. My name is Vishwadeep. I welcome you all on Unacademy Computer Science Channel for unlimited learning. This is the regular course of data structure, and in the today's class I am going to discuss about various types of binary trees, which are complete binary tree, full binary tree, expression tree, and in those we are going to talk about small subtopics like in expression tree what traversals mean, the array representation of complete binary tree, and so on. So without any delay, let's get started with the topic, these different types of binary trees. I hope you all are fine. I hope your festival was good, and I hope your preparation is on the track. With that said, before I start the explanation of these topics, I would like to introduce myself. My name is Vishwadeep, written the gate multiple times. This is my highest rank. My other ranks are 119, 440, 682 in computer science gate. Masters, IISc Bangalore, another masters from BITS Pilani in data science, a rich experience of teaching, and these are the courses I am taking on Unacademy's platform. If you want my free classes, then you can subscribe this particular channel, just because so many free classes I am taking over here, live, interactive. Apart from that, if you want more interactive classes, then you can go to Unacademy. You go to Unacademy, search my name and follow my profile. You can check out that particular profile link here. If you follow my profile, you will check out, or you will get over there, special classes. These special classes are absolutely free. So many special classes I have already taken. Those you can listen in recorded mode. Plus there are so many special classes which I am taking for free for you guys, so that you can learn from there, and those you can attend live class. So what is there in this particular special class? Special class are absolutely free for you guys, and you can learn a lot. If you want to check out recorded free classes, special classes on Unacademy's platform, what you can do is you can go to this particular URL, and on that particular URL you will get a page called as Notion page. Over there I have organized all my special classes in more structured way, so you can check out that particular link once, and you will definitely get all the required classes. Even some surprise classes also you can get, even if you will not expect those classes over there. So many theory, practice, questions, MSQ, and so many things over there are available. One test series are also we are having. That particular test series you can write the test for free, and that test series contains almost 21 tests for free, 30 questions each, subject wise test. And this particular test series you will get absolutely free, quality questions and really good practice you will be having through this particular test series. Go enroll, write the test, and enjoy the learning. But if you want your preparation to be on the highest level in such a way that you will get highest possible rank for you, then you need to come on Unacademy Plus. Unacademy Plus is the platform we provide for the learners, so that learners can have a closed group environment in which the environment of learning will be so much that the students will always feel motivated, will always have structured classes, will always have an organized preparation thing. So if you want to join Unacademy Plus, one thing for sure you need to have is you will have your preparation in more motivated way, in more efficient way, more productive way. That if you are learning for 1600 or 16 hours per day, then those 16 hours you will utilize for only learning. You will not waste much of your time in the day-to-day routine. But if you are learning for free from open sources, among 16 hours per day you will have only 10 hours per day productivity, because you will waste a lot of time in getting the proper content, in solving your doubts, in getting the proper test and multiple scenarios. So that's why I'm telling you, go for Unacademy Plus subscription and study in most organized way. One more benefit I can provide from my end, that for Unacademy Plus is that particular benefit is you will get one particular team, one team, not an educator or not a teacher, not only one or two teacher, you will get a team. That particular team will help you in entire course preparation of your computer science gate preparation, and that particular team works as a unit, and that team will help you in every possible manner. And if you want to go for Unacademy Plus subscription, then what you can do is you can use this particular code VDEEP10. This code will help you to get the discounts maximum possible, minimum 10%. Apart from that, this particular code will work as a bridge for your preparation to my team's effort. My team is working a lot in terms of your success, for your success, and this particular code, if you use VDEEP10, that particular code will be used as a bridge, as a connection for your preparation to my team's effort. So my team's effort will be directly proportional to your success if you use the code VDEEP10 for your subscription. Of course, you will get the lots of other benefits apart from the discounts. You will be getting my team support, you will be getting my mentorship, and lots of other things if you use the code VDEEP10. Plus another thing is there, we have another type of subscription which is iconic subscription, and this particular subscription actually makes your preparation even more easier. Why? Just because if you are a software engineer person, you should know that a best plan can make your execution very easy. If your planning is good, then definitely your execution and definitely your end result should be good. You have seen that in software development, you may seen it everywhere in this world. So if you are preparing for GATE and if you want to go for iconic subscription, that iconic subscription can give you or will give you all the benefits of Unacademy Plus. And apart from that, a personal coach facility which helps you in the preparation strategy, will help you in the making the plans, will help you in the booster sessions, will help you in analyzing the test, personalized only for you, will help you in giving you more practice sets and personalized specialized notes. And this iconic subscription you can get again with the discount and other benefits if you use the code VDEEP10. Use the code, remember the code VDEEP10. You need to use this particular code if you want to have that connection done for your preparation and with my team's effort. Okay, fine. If you are fine with all these details, then let's start our today's session. You all know only one thing I need from your end is your excitement, your energy, your enthusiasm for the learning. And that particular enthusiasm comes when you think from your mind, yes sir, we will learn today. आज हम सीख के ही रहेंगे, हम पक्का सीखेंगे. If you have that excitement always, nobody can stop you in learning any kind of concept. Any kind of. So if you are ready, type down in the comment box you are ready, and then we will start today's session. So for today's session, before today's session, I want to highlight the points which we have already done. We have already done with basics, binary tree, traversals, construction of tree using traversals, how to represent a general tree into binary tree, then recursion questions on the tree. All these things we are done with. Now what we are going to do next thing is expression tree. What is the expression tree? ये चेहरे के एक्सप्रेशन की बात नहीं है बाबू, ये है बात आपके किस एक्सप्रेशन की? आपके computers के expressions की, using which you denote the operations. So expression tree is what? If you denote the expression in terms of expression tree, then what you need is, you need two things. One is operator and another thing is operand. You have in the expressions two things, operator and operands. So if you have operator and operands, it's very simple thing. Operator you will make as node and operands you will make as its children. So if I am saying, if you have left and right operand, then you will have those left and right operand as left and right what? Left and right what? Left and right children. Okay, so if suppose you have a very simple expression a plus b, how to denote a plus b in terms of tree? What is the operator? What is the operator? Plus. So operator plus is node. Left operand a, so left child is a. Right operand b, right child is b. Now we will increase the complexity a little bit, complexity of the question. Suppose we have an expression a plus b into c, how to draw the tree? Now if you have more than one operator, you need to use already learned topics. What are the topics? You need to use precedence and associativity rule to solve the expression, and exactly same rule you need to use for drawing the tree. It's very simple concept. आप थोड़ा सा concentrate करेंगे, you will concentrate a bit and you will understand it's very easily. If you are having a plus b into c, first of all plus and multiplication, two operators are there. Among two operators, which operator you will solve first? कौन सा solve करोगे जल्दी बताओ, कौन सा ऑपरेटर पहले सॉल्व करोगे? मल्टीप्लीकेशन. इफ यू सॉल्व मल्टीप्लीकेशन फर्स्ट, draw the multiplication का expression tree first. So what you need to do is you need to draw the tree for this b into c first. How do you draw? Multiplication is the operator, left operand b, right operand c. If you have solved this one, it's very simple now that this b into c result becomes the right operand for this plus. So we have another operator on the top of this. Its left operand is a and right operand is the result of this sub expression b into c. So that's how you will draw the tree based on associativity and precedence rule. First precedence, then associativity rule. You need to check out which operator you will solve first. Based on that, next and next and next and next, and you can continue the drawing the tree. I guess आपको समझ में आ रहा है. I hope you guys are understanding this concept. It's very easy. The same kind of expression tree you will draw in the compiler design discussion also, as the term or as the name of the tree is syntax tree over there. Okay, fine. Should I go next? Next is we are having some good questions to be solved. What I want from your end is you pause the video here if possible for you and draw the tree for you, for yourself. Take your pen paper, draw, and then fast forward it. Maybe go for the solution and check out that did you get the same tree or not. If yes, perfectly fine. If not, then check out the solution which I am going to solve in the next few minutes and see where you made the mistake, and then try to understand, okay, I will not make this kind of mistake next time onwards. Okay, fine. आगे बढ़ते हैं. पहला क्वेश्चन सॉल्व करते हैं. Let's draw the tree for this one. So first of all, 2 plus 7 into 3 exponent 2 minus 4. This upward arrow is exponent power. Okay, among all these operators, exponent is having highest precedence. So let's solve exponent first. I will solve exponent first. Left operand 3, right operand 2. I will draw the tree like this way. Here in this corner, for exponent, left operand is 3, right operand is 2. Now next I am going to solve multiplication. If I am going to solve multiplication, for this multiplication, left operand is 7, right operand is 3 exponent 2. Right operand 3 exponent 2. So for the multiplication, right operand is this, left operand is 7. Done. So this much is done. Itna ho gaya. This much is done. Okay. Now plus and minus, which is having highest precedence, plus or minus? Both are equal. Both are equal. तो अब किसको solve करेंगे? आप बताओ. You only tell me which will be solved next. The next operator that will be solved based on the associativity, plus and minus having same precedence. Associativity is left, so you need to solve leftmost this plus. Leftmost operator first. Solve this particular plus first. What we will do? What we will do? What we will do? What we will do? We will do this. This plus will have left operand 2, right operand this one. Next what? this minus, so this much you have done. For this minus, this much is left operand and right operand is 4. So for minus, left operand is the result of this expression and right operand is 4. This will be the tree you will be having for the first expression. I hope you got this particular tree as it is. आपको ये सेम ट्री मिला होगा. अब बात करते हैं सेकेंड एक्सप्रेशन की. दिस इज लिटिल कॉम्प्लेक्स बट नॉट दैट मच कि यू कैन नॉट सॉल्व इट. कोई क्वेश्चन अनसॉल्वेबल नहीं होता है. एट द मोमेंट यू कैन नॉट सॉल्व, बट लेटर ऑन इफ यू हैव प्रॉपर लर्निंग यू कैन डेफिनेटली सॉल्व इट. इजीली आपको मिल जाएगा. ओके, चलिए. Simple. Let's start with the highest precedence operator. So here among plus minus, multiplication, division and exponent, you have highest precedence of exponent. Now there are two exponent. So which exponent you need to solve first? You will solve the exponent which is having rightmost side, which is in the rightmost side. Why? Just because exponents are the rightmost associative, so rightmost exponent, this one you need to solve first. 3 exponent 2. Let's do that. For exponent, left side is 3, right side is 2. Done. Now you need to solve the next exponent. For this next exponent, left operand is 6, right operand is result of 3 exponent 2. So for this exponent, left operand is 6, right operand is result of this sub expression. Now this much is done. ये इतना हो गया है. What you will solve next? You have multiplication and division, but as you know, multiplication and division both are having same precedence. Based on associativity, you need to solve the leftmost first, this one first. Multiplication you are going to solve first. So let's solve multiplication first. I will solve multiplication first. Multiplication of 5 and 7 first. After that you need to solve this division, just because multiplication division are left associative. So next one you will solve division. Division के लिए left operand is 5 into 7, right operand is 1. So left operand is this for division and right operand is 1. Now if you are done with this much, इतना अगर आप लोगों का हो गया है, this much is done, this much is done. Now remaining 3 operators, minus, plus and plus. Which operator you are going to solve next? Which operator you are going to solve next? कौन सा operator solve करेंगे? All are having same precedence. According to the associativity, you are going to go with the leftmost first. Minus. So for minus, leftmost operand is 2, right operand is this. So first you are going to solve this minus, left operand is 2, right operand is this. Now this much is done. Next operator you are going to solve is this particular plus. Let's solve this particular plus. So left operand is result of this subtree, okay, and right operand is result of this subtree. So for the plus, left operand is this one, right operand is this one. Now next one is plus 9. So for this plus last level, plus, you will be having left operand result of this sub expression plus 9 as the right operand. This will be your subtree. This will be your subtree. Okay, I guess you will, okay, I guess you will be clear about this. I guess you will be clear about this. आपको ये clear हो चुका होगा, right? Are you done with this? Are you clear about this? Did you stop your video? Did you get the same answer or not? If you have created the tree before me, along with me, however, did you get the same answer? Just check out क्या आपको same answer मिलेगा या नहीं मिला या नहीं. Just check it out. These are very easy questions. You can have more questions of the same type. If you want a practice question, I can give you for practice. Okay, so for practice I am giving you another question. Do it at home. Okay, so the question is like this. This is unary operator minus b. So unary operators will always have highest precedence over the binary operators. Remember this, plus c into d divided by E, then plus G exponent H exponent I minus J into K. This is the expression. You can draw the tree easily. One thing, if you don't know, equal to is having minimum precedence, least precedence. So this equal to will be solved after entire rightmost expression is solved. सबसे लास्ट में वो सॉल्व होगा. ठीक है, आगे बढ़े. Another thing is we have some very peculiar, very special expression trees for the unary operators. One unary operator is minus b. Unary operator means क्या होता है? Sir, unary operator is that operator which requires only one operand. Operator which requires only one operand, like negative minus b. So if you have negative minus b, how do you draw the tree for this? Minus b, minus is the operator, only one operand is there, which is the right operand, so right operand is b. Similarly, log x, what is the operator? What is the operation? X or log? Arey baba, log is the operator, so operator is on the root, and then x is the right operand, should be in the right child. Next, x factorial. Factorial is the operator, that particular operator to be solved, and then this operator is having left operand x. Next is log of x factorial. Log of x factorial will be solving. Then in the log of x factorial, first you will solve x factorial. After that you will take its log. So how you will draw the tree? First of all, factorial x, and this will become the right operand for log. So log will have right operand as the result of factorial x. This way you can draw the tree of all these four expressions. If you have such kind of expression trees used in some bigger some kind of expression like that way, of course you will be able to draw it. Okay, let me give you simple example for you guys. If suppose I am asking you to draw the expression tree for this question, a minus b into log of x plus 2 minus 9. Can you draw the tree? Of course you can. Can you draw the correct tree? That should be a correct question. वो ज्यादा appropriate question होगा कि क्या आप सही बना पाएंगे या नहीं. चलिए पहले solve करते हैं. Which one will you solve first? Of course you will solve the bracket first. X into x plus 2. So draw the x plus 2 first. I will draw plus, left operand is x, right operand is 2. Done. Now log of this. Why? Just because log is having more precedence than the binary operators. So by all these are binary operators, minus, multiplication and minus. So log I'll have to solve next. Log of this, right operand is x plus 2. Now I will perform the multiplication next. So how do you perform multiplication in this case? For multiplication, left operand is b, right operand is the result of this log. So for multiplication you will be having right operand this, left operand is b. Next level, और आगे बढ़ेंगे? Yes, बढ़ेंगे. Next level is this. I will perform this minus. Why? Just because this minus will be solved next. Left associative है ना? That's why. That is why. So how you will solve for this minus? Left operand is what? Left operand क्या मिलेगा बताओ? Left operand is a, right operand is result of this. At the end, this minus. Okay. So for this minus, which will be the left operand? For this minus, left operand is the expression, entire expression. Right operand is जाग रहे हो या नहीं? आंसर दे दो रे बाबा. 9. Got it? आगे बढ़े. तो इस टाइप के कोई भी expressions आते हैं, you can use such kind of small these expressions, sub expressions, so that you can get a correct answer. Understanding is important, and I hope you got it correctly. If you not, then please ask me. Then we have a very great question of GATE Computer Science from 2014. One quick question. Is my video audio clear? Just because I am not able to see it proper, that's why I am just asking, my video and audio is clear? Is that visible perfectly correctly? क्या ये ठीक दिख रहा है? Okay, fine. Now, question says what? Consider the expression tree shown. Each leaf represents a numerical value which can be either 0 or 1. So leaf, you can see it can be either 0 or 1, right? Over all possible choices of values at leaves. So you can have 0 or 1 here, you can have 0 or 1 here, you can have 0 or 1 here, you can have 0, 1 here, 0, 1, 0, 1, 0, 1. So over all possible combinations, you can have 2 power 8 various combinations here. Just because 8 bits or 8 different values are there, both can be 0 or 1. 2 possible values, right? So maximum possible values at expression presented by the tree is. What can be the maximum possible value presented by this particular expression is? First of all, I'll solve it directly, and after that I will tell you a particular trick, not exactly trick, a particular way to solve such questions in which the probability of error will be minimum. First of all, let's solve this. How? Suppose here is the plus. If here is the plus, first you will solve this expression from bottom to top. पहले ये प्लस को सॉल्व करने के पहले आई नीड द लेफ्ट मोस्ट एंड राइट मोस्ट सब ट्री का रिजल्ट, राइट? सो फर्स्ट ऑफ ऑल स्टार्ट फ्रॉम बॉटम. फॉर दिस प्लस आई विल टेक 1 here and 1 here, so that 1 plus 1 I can get as 2. Then here I have minus. What my first instinct says, if I'll take 1 minus 0, I can get 1 here. But if I can get 1 here, 2 minus 1 will give me only 1. So एक काम करते, माइनस से माइनस को कैंसिल करते हैं. Let's cancel out minus to minus. Let's cancel out minus to minus. What I will do is I will take 0 here, I will take 1 here, 0 minus 1 I will make minus 1, and 2 minus minus 1 I will make it as 3. You will think it like that way, sir. अगर minus 1 नहीं किया होता तो, if I'll take it 0, 0 minus 0, 2 minus 0, I will get 2, which is not maximum. They are asking about maximum value, so I am maximizing it. Here is minus, above is plus, so I can take it as 1 and 0. 1 minus 0 is 1. Here is plus, so I can take it as 1 and 1. 1 plus 2, 2. 1 plus 1, 2. 1 plus 2, 3. And at the end, 3 plus 3 is 6. So my answer for the expression is 6. But if such kind of question will come in the exam, I will not recommend you to solve the question like this way. मैं बिल्कुल नहीं चाहूंगा कि आप ऐसे solve करें. Why? ये तो मैंने solve किया हुआ था, तो I know कि which value will be put where. If you will solve this particular question for the very first time, you will initially get either 3 or 4 or 5. You will be getting up to 5 or 4 values. Sometimes you may get up to 6, when only few people will get value 6. What I would like to have in such kind of scenario is, instead of leaves, you take some variables here. You take some variables here. This leaf is variable A, this is variable B, this is variable C, D, E, F, G and H. Take a particular expression out of this tree. Let's take the expression. How do you take? A plus B. Fine. First of all, I will perform A plus B, and then minus of this, minus of C minus D. C minus D first in the bracket, after that this. And this particular leftmost subtree plus rightmost subtree, and rightmost subtree is having what? E minus F in the bracket first, plus G plus H. This is my expression. Now do one thing, simplify this expression. Simplify this expression means, अरे प्लस माइनस खोल लो, ये ब्रैकेट हटा दो. A plus B minus C minus minus plus D plus E minus F plus G plus H. This is the expression denoted by this tree. Now you only tell me, each variable can take either value 0 or 1. I want this expression to have maximum value. Can you tell me what can be the maximum value and how can I achieve it? कैसे achieve कर सकते हैं maximum value? If each variable can be of value 0 or 1, for maximum value, what I will suggest is put all the positive values as 1 and negative values as 0. What I am doing is all the positive variables as 1 and all negative variables as 0. करके देख लो. If you will do this, what expression you will be getting, what values you will be getting? 1 plus 1 minus 0 plus 1 plus 1 minus 0 plus 1 plus 1, answer is 6. You can see variable C you will put at 0, yes I have taken at 0, and F you will take as 0, yes I have taken at 0, and you can get maximum value 6. Now hit and trial is easy or this particular expression method is easy? Of course this one is easy. ये ज़्यादा easy है, आसान है. So remember, every time you get the question, to make most out of the question, to make maximum marks, to make least mistake, you need to think of such kind of methods, and in that particular case you will definitely get correct answer with minimum errors. Got it? Now in this same question I have modified the question and now I'm asking minimum possible value of this expression. Of this expression tree, what is the minimum possible value? It is a modified question which I modified here. Just tell me which particular value is minimum possible for this expression. What you gonna do? I got the expression a plus b minus c plus d plus e minus f plus g. That is the expression. Plus h. That is the expression. That is the expression. I want minimum value. क्या करें आप बताओ? अरे आप बताओ भैया क्या करें? What should I do in such case when I have all the variables which can take either 0 or 1 and I want this expression to give me minimum possible value? For minimum value, what I can do is take all positive 0. All positive variables take as 0 and all negative as 1. करके देखो क्या मिलेगा. If we will do this, we will get 0 plus 0 minus 1 plus 0 plus 0 minus 1 plus 0 plus 0. Answer is minus 2. Minus 2. Yes, Anubhav, you are correct. You are correct. Yes, minus 2 is the answer. Very simple. It's very very simple. बहुत आसान है, बहुत आसान है. Got it? I guess you got it. आपको समझ में आया होगा क्या किया. Now if I'm saying minus 2 is the minimum value, 6 is the maximum value, can you get 5? Can you get 5? Yes. एक कोई भी पॉजिटिव वैल्यू को you keep as 0. इस पर्टिकुलर केस में one more positive value you keep at 0 and you can get 5 also. You can get? Yes, you can get. Multiple options can be possible. Other than that, can you get 4? Yes, I can get 4. Two positive values, you can get 0 and you can get 4 value. Can you get 3? Yes. Can you get 2? 1, 0, minus 1, minus 2. Yes. So another modified question I have brought with all possible choices of the values at the leaves. The number of possible values of the expression represented by the tree is. कितनी values आप represent कर सकते हो? -2 to 6 all the values, and which are how many? कितनी values हैं? 9. So answer for this question is 9. 9 possible values are there for this particular expression. क्या समझ में आया आपको ये चीज? बोलो भैया बोलो. Got it? चलिए अगली बात करते हैं. What is a complete binary tree? Complete binary tree is a binary tree in which every level except possibly the last is completely filled. Means if you should have a complete binary tree, the complete binary tree have all the levels with maximum nodes. If any relief should be there on any level, then that relief should be or can be on the last particular level. सबसे लास्ट लेवल पे मैक्सिमम से कम नोड्स हो सकती हैं. And if you have last level less than maximum nodes, then all the nodes are as far left as possible. All the nodes are arranged from left to right. So very simple definition, complete binary tree says all the levels have maximum number of nodes. If any level which can have less than maximum possible nodes, and that level is only the very last level. Last level, yes. And at the last level also, if you are arranging the nodes, then nodes should be arranged from left to right. Means leftmost node should come first, then next, and so on. I will ask some question. You will let me know that this is a complete binary tree or not. Okay, so is this a complete binary tree? Yes. This single level, first level, this is the level number 0 on this, maximum number of nodes is 1, possible. Yes, this is a complete binary tree. Is this a complete binary tree? Ji haan. All the levels having maximum number of nodes. Is this a complete binary tree? No. Why not? Just because if last level is not having maximum nodes, no problem, possible, but node should be arranged from left to right. We should have leftmost node first, after that right node. Means if somebody will ask, this is a complete binary tree, ji haan, ye correct hai. Last level is this one and it is having less than maximum number of nodes, fine. Above level is having maximum number of nodes, yes, and nodes are arranged from left to right. So this is a complete binary tree. If I will ask you, this one is a complete binary tree, yes. Why? This level having maximum nodes, yes. This level having maximum nodes, yes. This level, last level, it is not having maximum number of nodes, no problem, but nodes are arranged from left. Got it? If I'll be asking you, this is a complete binary tree, answer is no. Why not? This level is not having maximum number of nodes. So I guess you understood. One more example I would like to give you. क्या ये कंप्लीट बाइनरी ट्री है? नहीं है. Is this a complete binary tree? Yes. Is this a complete binary tree? No. Last level is not having maximum number of nodes. ठीक है, ऊपर वाले लेवल पे maximum number of nodes है तीनों पे, यहाँ भी, यहाँ भी, यहाँ भी. This level having maximum nodes, maximum number of nodes, maximum nodes, but this particular level is not having maximum nodes. But fine, it would be fine if you'll be having leftmost node first. आई गेस आपको ये क्लियरली समझ में आया होगा. नहीं आया है तो पूछ लो भाई, पूछ लो. इफ यू गॉट दिस, देन let's go further and let's try to understand a particular question and its understanding maximum and minimum number of nodes in a complete binary tree of height h. So for maximum number of nodes in a complete binary tree, we have already seen such kind of a question. In any binary tree, if we want to have maximum number of nodes, we will have all the levels full, completely full. Height of a tree with single node is 0. So what is the height of this particular tree? Can you tell me? 1, 2, 3, 1, 2 and 3. 3, right? 0, 1, 2, 3. 3. Okay. Maximum number of nodes with height 3. Find what is the total number of nodes. What is the number of nodes? Maximum number of nodes n max with the height h in a complete binary tree is what? How many number of nodes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. 15 number of nodes are there, which is 2 power 3 plus 1 h plus 1 minus 1. 16 minus 1. That is the number of nodes, maximum. If you want to have minimum number of nodes in a complete binary tree of height h, how do you construct? Suppose h is equal to 3, I am taking minimum number of nodes in a complete binary tree with height h is equal to 3 should look like this. Yes, good, Sarvesh. H is equal to 3. So, what is the difference here? Last level is having all the maximum number of nodes. Here, last level is not having maximum number of nodes. Not having maximum number of nodes, having only single node, so that we can have minimum number of nodes of height h. Minimum node चाहिए तो last level should have less number of minimum number of nodes. Can we remove these nodes also? Can we have a complete binary tree with height h is equal to 3 like that way? नहीं रे बाबा, it is not a complete binary tree. ये complete binary tree ही नहीं है. क्यों? The definition says the complete binary tree should have maximum nodes at each level except possibly last. So on the last level, we are not having maximum number of nodes. Remaining level having all the maximum number of nodes. And how many number of nodes we have here? 1, 2, 3, 4, 5, 6, 7 and 8. So what exactly we are having here? हमारे पास we are having here with height h minus 1 maximum number of nodes binary tree. A binary tree with maximum number of nodes of height h minus 1 and then one extra node on the next level. So with height h minus 1, keep h minus 1 here, maximum nodes with height h minus 1, okay, and minimum with height h is, I can understand it like that way, height h minus 1 के लिए maximum number of nodes this one plus one extra node this one, which in turns will give you 2 power h. Minus plus 1 gone, 2 power h, minus 1 plus 1 gone. So 2 power h, you can see 8 number of nodes with height 3. This is the minimum number of nodes with complete binary tree with height h. Now there is another definition in complete binary tree which is called as strictly complete binary tree. Strictly complete binary tree. What does this strictly complete binary tree? This strictly complete binary tree says that every level, it says every level including the last one should have maximum number of nodes. Every level has maximum number of nodes, even though the last level also, that is the strictly complete binary tree. Understanding? So what is the difference between complete binary tree and strictly complete binary tree? The complete binary tree can have less than maximum nodes on the last level. But strict complete binary tree says on the last level also you should have kitni? How many? Maximum nodes also. Last level also have maximum number of nodes. I guess you guys are understanding. Yes or no? अरे बोलो रे बाबा. चल आगे बात करते हैं एरे रिप्रेजेंटेशन ऑफ कंप्लीट बाइनरी ट्री. इट्स अ वेरी सिंपल कंसेप्ट and very easy to understand too. What array representation of CBT says? Array representation of complete binary tree says that you will be having your root of the tree stored at index 1. And if there is a node at index I, then the node's left child is stored on index 2i and the right child of the node is stored in the array on index, very next index of 2i, which is 2i plus 1. Very simple. Let's take a complete binary tree to understand this. A, C, B, E, F, D, G, and H. This is a complete binary tree. Okay, I will have an array. Here it is the array. In the array, root I will store at index 1. Right? So root I will store at index 1. At index 1, I will be storing root, which is A. Now if I am storing any node at index 1, at index I, its left child A's left child is C, it should be stored on 2i, 2 into 1. On index 2, you will store left child of A, which is C, and right child will be 2i plus 1, means at index 3 you will store the right child of A, which is B. Now for node at index 2, its left child is on 2 into 2 and right child is 2 into 2 plus 1. On index number 4 and 5, you will be having its left and right child. C's left child is E and F. You will be storing on index number 4, 5. Let's talk about this one. Now I am talking about this one. Index number 3. Index number 3, element B. Index number 3's left child will be on 3 into 3, 2, 6, and right child on 7. So index number 6 will have left child of B, left child at index 3, left child of B, which is D, and right child is G at index 7. One last, at index number 4, you have element. Yes, you have the element. Yes, you have the element. So its left child will be stored on index 8, and that is H. You can represent a complete binary tree into the array like this, and it is very simple. You do one thing, you just store the elements in the array in this sequence from top to bottom, left to right, left to right, left to right, level wise. So it's like this way. You are storing A first, then CB on the next two indexes, then EFDG, and then H. Understood? So this is index number 1, then 2, then 3, then 4, then 5, then 6, then 7, and then 8. Like this way, you can store this complete binary tree into the array. I guess you guys are understanding. Now, if you guys are understanding, I would like to ask you a simple question. By looking at this particular tree, can you give me an answer? If there is a node which is at index I, if its left child is at 2i, right child is at this, can you let me know where its parent is stored? Parent of index 4 is stored where? Parent of index 4 is stored on 2. Parent of index 5 is stored on 2. So parent will be stored on I by 2 and its floor value 5 by 2, which is 2.5. 2.5 floor value is 2. Got it? समझ में आ रहा है? Of course, root का कोई parent नहीं होगा. That's why 1 by 2 becomes 0. Hence, there is no any parent of root. Now, sometimes in the questions, instead of giving you array representation like that way, they will give you like this way. There is a CBT, there is a complete binary tree, and that particular complete binary tree is stored in the array like that in the sequence A, then C, comma B, comma E, comma F, comma D, comma G, comma H. So I guess you will be able to understand. This is root, left and right are CB, left to right of C's child EF, B's child DG, and then E's child H from left to right. Arrange these nodes from left to right, level to level in binary tree. You will get the tree easily. I hope आप बना पाओगे ट्री. बन जाएगा? Yes, बन जाएगा. मेरे ख्याल में बन जाएगा. Definitely you will be able to make it out. Now, based on whatever you have learned now, I would like you to solve the question. You try first. I will get the answer next. If you are watching it live, then stop the video here. You can do it. If you are watching it in the recorded mode also, you can solve the question by your own before I will solve the question for you. Look at this. A scheme for storing binary trees in an array X is as follows. Indexing of X starts at 1. अभी थोड़ी देर पहले यही चीज बताई. Instead of 0, fine. The root is stored at X of 1. Told you. For any node stored at X of I means it index I if any node is stored. The left child if any is stored on X of 2I on index 2I. The same thing I told just now. Right child if possible if any is stored on X of 2I plus 1. Same thing I told just now. To be able to store any binary tree on n vertices, the minimum value or minimum size of X should be. The question is, you should be able to store any binary tree. कोई भी binary tree आपको store करानी है. If you want to store any binary tree of n number of vertices, what should be the minimum array size required? Let's take a simple example. If I am taking n equals to 4, then I want my array to be that much of size that I can store any binary tree with 4 nodes. Any binary tree means if I want to store this binary tree, I should be able to store this binary tree. If I want to store this binary tree, I should be able to store this binary tree. If I want to store this binary tree, I should be able to store this binary tree. If I want this binary tree, I can store this binary tree also. If I want to store this binary tree, I can store this binary tree also in that array. कोई भी बाइनरी ट्री जो मैं चाहता हूं स्टोर कराना, मैं स्टोर करा सकता हूं एक उस एरे में if I have that much of array size. So what I will do, I will check out the worst case. I will check out the worst case that among all the trees, what is the worst case, and this is the worst case. This is the worst case. In this particular case, I will require more size of array, and in that particular case, if I can store this array in the or this particular tree in the array, then I can store any binary tree of 4 nodes in the array. How can I come up with this worst case? अरे आप खुद देखो, if I'll be having root node at index 1, its right child will be on 1 into 2 plus 1 at 3 into 2 6 plus 1 at 7 its right child, and 7 into 2 plus 1 on index number 15 I'll be having its right child. So if I have minimum 15 size array, then I can store any binary tree of 4 vertices. My answer should be D. Now you will say, sir अभी तो आपने बोला कि array representation of complete binary tree ऐसा होता है. Now read the question. They are asking about binary tree. They are not asking about binary search tree. They haven't asked about binary search tree रे बाबा. Binary search tree, oh sorry, complete binary tree नहीं पूछा है. They haven't asked about complete binary tree. They have asked about regular binary tree. So binary tree can be anything. कुछ भी हो सकता है, कोई भी चाइल्ड हो सकता है, राइट? दैट्स व्हाई माय आंसर विल बी डी. सो आई आस्क यू ऑलवेज, आई एम आस्किंग वंस अगेन, ऑलवेज रीड द क्वेश्चन. What happens in this type of question? You read the statement. Yes, sir, हमने ये पढ़ा था complete binary tree के केस में ऐसा होता है. Yes, we have read this expression or we have read this method to store a complete binary tree in the array. हाँ ठीक है, ऐसे. Then we will take with this example. My answer will be n size. I will go with this B option. Correct? आगे बढ़ गए. You need to read what exactly given in the question, and based on that only you should solve the question. They are asking about any binary tree, not complete binary tree. That's why this answer is there. Okay, fine. If you are done with this, let's go for the next thing, which is full binary tree. Fine. Now look at this. What is a full binary tree? Full binary tree has a definition. A binary tree in which every internal node in which every internal node has two children. Okay, so what is the meaning of internal node? Internal node means very simple. Internal node means the node which is having child, so if you have internal node, it is a restriction that internal node should have two children. We will not allow any internal node with one child. So either node will have two children or node will not have any child, leaf node. That is the full binary tree. I'll give you the definition. I'll give you the example. This is a full binary tree. Yes, only one leaf node, no any internal node at all. We have internal node. Yes, then it should have two children. Look at this. This is a full binary tree. Similarly, another example. This one is a full binary tree. Yes, this one is a full binary tree. No, one internal node is having single child. So understand, there is no any other restriction, only one restriction. If any node is internal node, if any node having child, the children should be two. Full binary tree. समझे क्या? Understanding. Now, if you have attended my previous sessions, I have given you one particular handshaking lemma, and in that particular handshaking lemma I have explained you this key number of leaf nodes in a binary tree is equal to number of internal nodes with two children plus 1. This I have explained you very elaborate way, in very elaborative way ki how to do this, why it is there. So number of leaf nodes I am denoting by capital L. Number of internal node with two children I am denoting with I2 plus 1. Right? And at that time I have explained you this also ki total internal nodes in a binary tree, regular binary tree, I am not talking about full binary tree, I am talking about binary tree only. यहाँ भी this particular in a binary tree I am talking about regular binary tree. Full की बात ही नहीं की अभी तो. A total number of internal nodes in full binary tree is this I1 plus I2. What is the meaning of I1? Internal node with one child plus internal node with two children. Now, if I talk about full binary tree, do we have any internal node with single child? No. और यही तो डेफिनेशन लिखी मैंने, a binary tree in which every internal node has always two children. right, समझा ना रे बाबा, समझा ना? तो in full binary tree, if I talk about total internal nodes capital I can write capital I is equal to I2, only internal node with two children. So can I write total number of leaf nodes is equal to I2 की जगह I रखेंगे तो total number of internal nodes plus 1 होता. Getting it? In that particular case, total number of nodes capital N should be equal to total number of leaf nodes plus total number of internal nodes. Right or wrong? Can you get value of L in terms of I plus 1 here? Put the value of L here, so you will be getting N is equal to 2I plus 1, or in fact if you put I is equal to L minus 1, it becomes N is equal to 2L minus 1. I is equal to L minus 1, so it becomes 2L minus 1. N is equal to 2I plus 1, N is equal to 2L minus 1. Now, if I give a full binary tree in which total number of internal nodes are something, if internal node is given, you can calculate capital N, which is leaf node, and in turn, you can calculate capital N also total number of nodes. So if one thing is given, you can calculate rest of the two things. Easily? Yes, easily. Any one thing is given, you can get anything. L is capital L is total number of leaf nodes. L is total number of leaf nodes here, ye raha. Capital L total number of leaf nodes, I total number of internal nodes, I1 is number of internal node with one child, I2 number of internal nodes with two children. Capital N total number of nodes in the tree. Got it? Got it. So any one thing is given. For full binary tree you can get any other thing. Now I will give you one particular note here, and that particular note you will remember as it is, or you will understand based on the concepts, whatever is suitable for you. The thing is total number of nodes in a full binary tree is always odd. If you have a full binary tree, in full binary tree always you will have total number of nodes odd. You can take the examples odd number, odd number, odd number, or you can take it mathematically also. Something into 2, total number of nodes is n, something into 2 means even value plus 1 odd, or something into 2 even value minus 1 odd. So you will always get n value of n odd only. Always, हमेशा मिलेगा तुमको, हमेशा मिलेगा, ऐसा होगा ही होगा. This particular note you will remember. Total number of nodes in a full binary tree always odd. Got it? आगे बढ़ते हैं. Then there is a question. In a binary tree with n number of nodes, every node has an odd number of descendants. Every node is considered to be its own descendant. What is the meaning of descendant? Descendant is not only children, children and its children and its children and its children till the last leaf. Descendant means children and children and children and children and children and children till the last leaf. Those are called as descendants. वंशज जिन्हें बोलेंगे. Every node is considered to be its own descendant. हर एक node अपना खुद का भी descendant है. And every node has how many descendants? Odd number of descendants. What is the number of nodes in the tree that have exactly one child? चलिए try करके देखते हैं. Is this tree fitting with my given particular question? Yes. This node is having one descendant itself. खुद में भी अपना आपका descendant. Now, second example. This one. In this tree, leaf node is having odd number of descendant. Just because leaf node is having its own descendant 1. This particular node is having how many descendants? 2. Why? Its own descendant, yes, 1, and then one child, 2 descendant. No, we should have odd number. So we should add another child either here or here. If I am adding here, then this particular node will create the problem. This node will have two number of descendants, self and child. So what I should do? I should add it here. This is fine. Yes, correct. Next, if I'll add one more node here like that way, do we have every node with odd number of descendants? No, this particular node which is having single child will have even number of descendants. अगर इसके नीचे हमने इसको और even करने की कोशिश की, if we will add one more node to make the even number of descendants for this node, then this node will not satisfy the property. It's very simple concept. It is very simple concept. It is very simple concept. If we will not consider the node itself into the descendants, then the children and children and children and children should be of even number. The node, if not considered to be its own descendant, then we should have nodes children to be odd, not odd, even. हमने एक सेल्फ माइनस किया ना, odd to even we have made, right? Odd to even we have made. If we will not consider the node itself to be descendant on its own, then we will have number of children of the node should be even and their children to be even, their children to be even. Means the tree should be a full binary tree. So the question they have given in such a way that this will lead us to have a full binary tree, and you only tell me in full binary tree how many nodes should have single child. None. कुछ भी नहीं मिलेगा, कुछ भी नहीं मिलेगा. Answer is 0. No any node should have one child. All the nodes will have either 2 children or 0 child. That's why this particular question will lead us to have a full binary tree having 0 number of children. Then we have one extended version of full binary tree called as 3 tree. So one more thing I would like to add here, this full binary tree is known as 2T or 2 tree also. Similarly, we have a 3 tree. 3 tree says every internal node will have 3 children, means every node has either 0 child or 3 children. Every node has either 0 child or 3 children. Every internal node having 3 children. Like this way. Let's have a question. Let's have a question. Number of leaf nodes in a rooted tree of n nodes with each having 0 or 3 children. पहले ये question बाद में करेंगे. I will solve one another question. Suppose if we have internal nodes is equal to I, then total number of leaf nodes can be how many in such a tree? In such a tree in which all the nodes can have either 0 child or 3 children. Let's take a simple example. Here, internal node 0. In this case, number of leaf nodes 1. Let's take another example. Internal node 1 with 3 children, right? In that case, number of leaf nodes are 3. If we will add another internal nodes with 3 children, like that way, how many internal node? 1 and 2. And how many number of leaf nodes? 1, 2, 3, 4, 5. 2 increased. Then if we will have the tree like this way, that it can have 3 and 3, 6 and 7 particular leaf node if we have 3 internal nodes. So if we have 3 internal nodes, then we will be having 7 leaf nodes. Every time you are increasing the number of internal node, it is increasing the leaf node by 2. Means if we have some I number of internal node, for each internal node we will be having 2 leaf nodes plus 1 extra at the starting this one. If we add 1 internal node, total plus 2 from here to here. If we will add 2 internal nodes from here to here, 2 into 2. From here to here, 2 into 3 extra. Right? Got it? Got it, got it. So 2i plus 1 is the total number of leaf nodes. Now this question says you have total n number of nodes, and in which some nodes are having 0 child, some nodes are having 3 children. How many leaf nodes we can have? We want to get number of leaf nodes when the total number of nodes are n. We know that total number of nodes n is equal to total number of leaf nodes plus total number of internal nodes. Means what I need to have is I is equal to n minus L is equal to n minus I. Got it? Now listen, I can get internal node with leaf nodes. Yes, I can get internal nodes with leaf nodes. Yes. Can I get value of I here? Yes. I is L minus 1 by 2. I is what? If we have calculated L is equal to 2I plus 1, then what will be the value of I, which is L minus 1 by 2? Put the value here. L is equal to n minus L minus 1 by 2. And L is equal to 2n minus L minus 1 by 2, and you will get 2L equal to 2n minus L minus 1. You will be getting L is equal to 2n minus 1. Okay, I made a mistake. Plus 1 here should be divided by 3. I guess this particular mathematical thing you can easily understand. D option is correct. Yep. So one thing is given, rest of two things you can calculate easily. Either 2 tree is given or 3 tree is given or any kind of tree is given. Now let's make it generalized way. If you have a full binary tree means 2 tree. In the 2 tree, if we have 2 tree, then we have capital L is equal to I plus 1. Number of internal nodes plus 1. If we have 3 tree, then we will have capital L is equal to 2I plus 1. And you can make a remark of this. If you will have a 4 tree, then capital L will become 3I plus 1. If you have 5 tree, then you will be having capital L is equal to 4I plus 1. If you have k array tree, then what? K minus 1 into I plus 1. Here is the question. If we have complete k array tree, every internal node has exactly k children. Exactly the same thing which I explained. So total number of leaves in such a tree with n number of internal nodes with what? It is k minus 1 with internal nodes plus 1. That is the leaf nodes. Which is option? Which is option C. Good, Nishu. Nice. Great. Fine. Okay. Then we have two quick definitions to end off for the session. Left skewed binary tree. Left skewed binary tree says a binary tree in which every internal node has only left child. Only left child means like this way. This is a left skewed binary tree. Then we have another binary tree which is right skewed binary tree. Every internal node has only right child, like this way. Skewed binary trees. Okay, clear? Fine. So this is it for the session. In the next session we are going to talk about binary search tree. Very important topics. You don't miss this particular topic, just because this particular topic has maximum questions among all the different types of binary trees. Then based on binary search tree, we will have the discussion of AVL tree in the next upcoming sessions. Tomorrow I am going to have 2 sessions on the YouTube, 12 p.m. That particular 12 p.m. session will be on gate PYQ on tree. And then we will be having a particular marathon session from 2 to 5. It's a Saturday, so we will be having 2 to 5 p.m. marathon session. This particular marathon session will be on the cache, just cache mapping. Okay, so it will be like this way: 3 hours cache mapping, and cache mapping done and dusted. ओके, रेड ब्लैक ट्री भी सिलेबस में नहीं है सर. रेड ब्लैक ट्री जिगजैग ट्री ये सब सिलेबस में नहीं है, आपको नहीं पढ़ना है गेट के लिए. Okay, so tomorrow we will meet on YouTube for these 2 special sessions on YouTube. PYQ for tree, 2 to 5 p.m. marathon for cache mapping, 3 hours entire cache mapping done and dusted. This particular team is helping you a lot in terms of your gate preparation. You need to give little bit feedback, little bit give give back to these fellas, me included. What you can give to these people, spread the words about these people. My entire team is working a lot for you guys, and that particular team is helping you a lot in your preparation. So please share all these videos, all these playlists which you are liking, which you are watching here, with all the possible audience, so that maximum number of students can be connected with us. If you want the PDF of all these lectures, this is the Unacademy Gate CS Telegram channel. Over here you can get all the PDF of classes. Apart from that, you will get all the announcements from us which are coming into the next few days. Then these are the Facebook pages to be connected with us. Be connected with us. This is the Gate Experience page. This is Gate Experience page for ME, CE and CSE specifically. Just join so that you can be connected with us for a very long time. And these are the channels which are with us, and this particular family is providing you lot in terms of free education. You can recommend all your electrical, electronics and instrumentation friends Creatrix channel, YouTube channel under our family. Mechanical के लिए this one, civil के लिए this one, Telugu, and then computer science your own channel, Unacademy Computer Science for SSC JE, this one, GS Terminal for general study, and you have all your friends to be connected. If you have friends in the different departments, please recommend these channels to those fellas. Next class इसकी कब होगी? Next class होगी हमारी इस पर्टिकुलर सब्जेक्ट की मंडे को. सो सैटरडे संडे वी विल बी हैविंग स्पेशल लॉन्ग सेशंस सो दैट यू गाइस कैन हैव अ रिविजन प्लस अंडरस्टैंडिंग or a revisit of each and every topic in short duration. Marathon sessions 2 to 5 p.m. Saturday and Sunday, and Monday again we will resume with BST and other topics of data structure. Please all these channels you make the share, you just share all these channels with the respective people. Share the video, share the playlist, like the video every time you join here, subscribe the channel if you haven't done this one on Unacademy Computer Science, and bell icon also you just press so that you will get notification every time whenever I'll be taking the classes. Thank you so much for joining here everybody. Happy learning. Have a nice remaining day. Bye bye.